today's webinar on Into the Fire, Deploying Oracle EBS to the Internet. My name is Phil Ryman. I'm the Director of Business Development at Integrigy, and I'll be the moderator for this e-learning session. Speaker today is Stephen Coast, and Steve is a Chief Technology Officer and founder of Integrigy Corporation. He's been working with the Oracle product since 1994, and for the past 12 years, Steve has focused on the security and auditing aspects of the Oracle E-Business Suite and Oracle database. He has written and presented on these topics at various national and regional conferences, including OAUG, IOUG, and the National Collaborative Conference. In fact, Steve will be giving 4 presentations at the upcoming Collaborative 12 conference in Las Vegas in April. So if you're going, to be sure to stop by and say hi. I'll now turn it over to Steve.
Thanks so much, Phil. So again, my name is Steve Coast, and today we're going to be talking about deploying Oracle E-Business Suite to the Internet. And we call it Into the Fire because basically as soon as you deploy on the Internet, you're opening up your application to about 1 billion people that have Internet access. And so that causes a lot of potential problems. There's possibility for attacks and things like that. So we're going to talk today first about web application security in general, and give you a little bit of background and kind of a foundation in web application security and what are some of the pitfalls, common attacks, weaknesses, those type of things. Then we'll talk about the E-Business Suite web architecture in a little bit more detail, describing how the architecture works, what are some of the strengths and weaknesses of it. Then we'll talk about the actual risks of deploying to the Internet. What do you have to worry about? What should keep you up at night? And then finally, we'll talk about the specific steps to securing the E-Business Suite when you deploy in the DMZ, which is a demilitarized zone, which is the connection between you and the Internet and how you should have it architected, and we'll talk about that. And then finally, we'll open up the question and answers. So before we get started, I'll give you a brief overview of Integrigy, tell you who we are so you get a little bit of familiarity with us. Integrigy was founded in 2001. And we specialize in ERP and databases, specifically security. So we've got a very strong foundation in Oracle Business Suite, Oracle Database, and Microsoft SQL Server security. And what we do with that knowledge is we actually have 2 products. One is AppSentry, which is basically a security auditing tool. And the other is AppDefend, which is an enterprise application firewall for the business suite. And we also have a series of security services around helping make sure that your environments are secure, both by doing on-site security assessments, working with compliance, so in terms of SOX, PCI, HIPAA, and we also do some security design services around what's the best way to configure auditing, how should you do encryption of sensitive data, and very similar to this presentation is how should you deploy Oracle into a DMZ environment. So one of the questions we do often get asked is why do you know so much about the Oracle E-Business Suite and potential vulnerabilities and things, and we'll talk about some of those today, is, well, Integrigy's found over 70 security vulnerabilities in the Oracle products. We're an active researcher. We spend a lot of time when we're not working with our clients trying to find security issues, what are the strengths and weaknesses of the Oracle E-Business Suite, and how can we give that information to Oracle to help them improve the product. So when the critical patch updates come out, Integrigy is often frequently listed as one of the people credited with finding the bugs. So we work very closely with Oracle to find security issues and weaknesses within the applications and actually forward it to Oracle to get it fixed. Integrigy actually wrote the best practices document, so anyone who's ever worked with Oracle trying to secure it hopefully has read in great detail the Oracle Security Best Practices document. Integrigy wrote that for Oracle. If you look on this page 2, it actually has our copyright notice. So enough about Integrigy. Let's start talking about web application security. So I'll first start off giving a very high-level overview of web application security and a way to look at it. And what we'll do is actually work with a couple organizations that have spent a lot of time thinking about web application security and have actually drafted frameworks and lists of different attacks and weaknesses in web applications. The first is actually a very good group. It's the Open Web Application Security Project, OWASP, and you can go to their website, owasp.org. And it's a group of security researchers, web developers, and other people who have actually got together and said, okay, we need to secure web applications, and how do we do that? And one of the things they've done is come up with a top 10 list of what are the top 10 attacks or weaknesses in web applications, and they've quantified them and spent a lot of time thinking about these different issues and how do you actually protect your web applications. And what we'll do is use this information to actually say, okay, what's the strengths and weaknesses within the Oracle E-Business Suite environment, and what do you need to be aware of in terms of risks and problems and attacks that can occur. So the OWASP top 10, number 1 is injection. So this is mostly SQL injection. There's other types of injection, but for the Oracle E-Business Suite, SQL injection is pretty typical. Then there's cross-site scripting. And then there's a number of other ones, and we'll kind of go through these in a little bit later to talk about each one specifically related to Oracle E-Business Suite. But this is kind of the way we think about Oracle E-Business Suite deploying it to the internet is, okay, here's specific vulnerabilities that people spend a lot of time thinking about and found in many, many different web applications. Then there's a little bit different approach to it. Another organization called the Web Application Security Consortium has actually developed a fairly detailed threat classification. This is about a 100-page document that goes through a very specific list of attacks and weaknesses and tries to describe out each one. So they go all the way from abusive functionality. So basically, how can I take the current functionality that exists, maybe iRecruitment, and actually use it to my advantage? Because it may be mailing somebody in the background. How can I use that to actually send out emails to other people? That's actually a potential problem and was corrected a couple of CPUs back by Oracle. The last attack is X-query injection, or using web services. Well, you can actually potentially, as part of web services, when you're sending XML to the web services in E-Business Suite, actually do X-query injection, get more information back than you should. Weaknesses go all the way from application misconfiguration, which is a very significant issue in Oracle E-Business Suite, to server misconfiguration. So these are all just different misconfigurations that you can do as part of the process. For the Oracle E-Business Suite, configuring a DMZ is very specific configuration, and you have to follow the steps step by step, or you're opening it up. And we'll talk about that in a few minutes. So this is kind of our foundation when we're looking at the Oracle E-Business Suite is, okay, here's all the potential problems, and here's what you need to be thinking about in terms of security. And we've kind of based everything we do back to the OWASP and the threat classification matrix to say, okay, here's where we need to focus our time and think about different issues. So I'll kind of go into 2 of these really quick to make sure that everyone on the webinar today has a good understanding of them. The first is SQL injection. SQL injection is probably the most critical type of vulnerability in the Oracle E-Business Suite environment because everything executes as the apps account. So if I can do SQL injection to the web application, I can get SQL to execute in the database as the apps user, who basically owns the application, owns all the data. And what SQL injection is I've got a URL. So this is actually a vulnerability that was fixed a number of years ago, actually in 2002, Oracle Security Alert number 32. And so hopefully everyone on the call here has patched it since 2002. I've given you 10 years before we kind of release the actual details of the bug. But basically what's happening is the URL is here, and so as part of 11i, this is a search string as part of the online help. So if you've exposed online help to the internet, this was the URL which ended at basically at search. There's a fundamental programming error behind the scenes, and this is actually calling modpl SQL, which therefore is calling a database package. And as part of that database package, they're creating a dynamic SQL statement. And fundamentally what will happen here is the code in red will actually be executed as part of the SQL statement. And in this attack, we just picked the FND user package update user, which is basically just changing the operations user's password to whatever we wanted it to be, in this case, welcome1. So this is a very effective attack because this is getting executed as apps at the database and is basically now just doing whatever we want. We could actually execute quite a few different things here because this is actually a really bad vulnerability because of the way the code is actually written. So this is a classic example of SQL injection in the Oracle E-Business Suite. That's fairly how easy it is to do. You just actually have to find the SQL injection flaw first, but once you've found that, there's a lot of different things you can do with it. The second major flaw in the Oracle E-Business Suite that has been patched over and over and over is cross-site scripting. For an Oracle E-Business Suite environment, cross-site scripting is probably a low to medium risk type of issue, where SQL injection is high to critical. It's much more difficult to exploit Oracle E-Business Suite with a cross-site scripting attack. Don't tell Amazon, eBay, companies like that who have actually been hit with massive and millions of dollars of losses due to cross-site scripting bugs in their applications. But for the Oracle E-Business Suite, you probably will be targeted a little bit, but it's a little bit more difficult because it's not as a generic application. You can't send out a million spam messages to a million different people and hopefully get one or two of them to click on it. Most likely you'll do a very targeted attack. You'll find a few specific people who you know will be using the Oracle E-Business Suite, send them email messages or try to redirect them to a website that you have control of over, and then execute your attack. So a classic cross-site scripting attack would work this way. And this is not technically a cross-site scripting because I'm using the same website, but it works as a cross-site scripting attack would. So in this case, the client is running iRecruitment, and so it's open to the internet, and I'm allowed to enter a job. And let's say that there's a cross-site scripting vulnerability in the application description field. So it actually lets me enter some JavaScript, and JavaScript makes web pages work. And I can actually enter that, and the database will save it as the description field. And then I've saved my job application, and now it's the HR manager's job is to open up the job application, look at the person, see if they're qualified. Well, the description field is actually displayed then on the HR manager's screen. And that JavaScript actually executes as part of their browser. And the application should be stopping this. In this case, we're saying it's a vulnerability. Normally it's stopped, but Oracle has actually had a large number of bugs in different fields because of this. And so now on the HR manager screen in their browser is executing this JavaScript, and the attacker, or the job applicant in this case, actually was very smart and knows a little bit about Oracle E-Business Suite and was able to put in a link that automatically got executed, and as part of that execution actually approved their job application automatically. So this would be a classic cross-site scripting attack. Another scenario is I can basically send to my boss, who has salary authority over me, a link and an email, or direct them to an internal website, and actually have them click on that link, which would then automatically update my salary in Oracle E-Business Suite. And the reason this all works is because you already have an Oracle E-Business Suite session, and I can actually update or execute any URLs as part of that session. So that's kind of a classic cross-site scripting. In the Oracle E-Business Suite, it's a little bit of a roundabout to get it to work correctly, but once you do, it's actually very powerful because I can get somebody who doesn't know what's happening to actually execute EBS functionality. So that's cross-site scripting. So when we talk about Oracle vulnerabilities, there's been a number of Oracle vulnerabilities patched over time. So for all the CPUs released since 2005 through this quarter, which was released last month, there's been 232 security vulnerabilities fixed. This is kind of the highest risk. This is something that's been published out. People know what they are, and if you're not applying the critical patch updates, you're vulnerable to these vulnerabilities. Well, what does this really mean in terms of how are these vulnerabilities used in a web application? Well, we went through those 232 security vulnerabilities and kind of counted them up. These are approximate because there's not always information released on every single vulnerability, and we don't know exactly if it, in sometimes which pages it is, and it takes a lot of time. But we've estimated pretty closely to how those vulnerabilities break out by type. And of those 232, about 150 so are actually directly exploitable in an external environment. So when you deploy Oracle E-Business Suite to the internet, there's about 150 fixed vulnerabilities that have been patched over time. So 60 of those are SQL injection. Again, those are very critical bugs. Any one of those, if I can access the web page, I can actually execute SQL as the apps account. There's been about 70 cross-site scripting. There's been about 15 authorization or authentication issues. Authorization, authentication issues are related to something that I shouldn't be able to access. And that has been actually a pretty frequent problem with the Oracle E-Business Suite because a lot of times, in especially 11i, each page had to do authentication correctly. So it had to say, well, is the user valid for this responsibility in this function? And if the programmer forgot to do that, I could just execute that page by going to it directly. And there's been a number of business logic issues, so things that I shouldn't be able to do, I can kind of trick this application into doing it for me. Those are a little bit more difficult to find, but they do exist, and they're pretty powerful once you find one of them. So that's kind of some of the web application security overview, some of the issues affecting the application directly, and how we look at it at Integrigy from kind of a standardized perspective. So now let's talk about the EBS web architecture a little bit. I'm going to kind of focus purely on the Oracle Application Server. So if we look at the Oracle E-Business Suite 11i web footprint, and this is just kind of focusing in on the application server. And this is a very important point because I had a call with a client on Tuesday, and they swore up and down this wasn't true, and somebody at Oracle told them this wasn't the way it worked. But this is the way Oracle E-Business Suite works. When you install an application server, you get every single module. So there's 250 plus modules, and when you install it, no matter what you do, is every module is installed and every web page is installed. Even if you say this is an external application server, or no matter what you do, you get all these different web pages. So the application server as part of 11i is actually 5 different web architectures. There's ModPL SQL, which is basically a technology that allows the client browser to call the application server, and that, which in turn calls a database package, and the database package generates the web page. There's Java server pages. These are one file, and they basically are Java that's compiled, and then it allows a web page to be returned. There's OA Framework, which is Oracle Application's own web architecture, and that's basically calling XML and Java files to actually generate a web page. There's Java servlets, which are very standardized Java servlets, which return web pages, and then there's standard Oracle forms. So as you kind of look here, there's 20-some thousand web pages within a standard Oracle Application Server installation. And this is for 11i. And so then all these web pages are calling the database directly using the apps account. So any vulnerabilities in any of these pages are using the apps account. So anything I can do, especially on SQL injection, I'm using the apps account in the back end. So anything that I can exploit, I have very powerful control over the entire database. So if you're running HR and you might have opened up iSupplier to the internet, well, I still have access potentially to the HR data if I can find a SQL injection vulnerability. So when we go on and look at release 12, so that was 11i. In release 12, there's a little bit of a change. Oracle went to a little bit more modern Java architecture and got rid of ModPL SQL, which is a huge benefit in terms of security because there was a significant number of vulnerabilities in it over the years. But again, I've got 20-some thousand web pages that are available as soon as I install an Oracle Application Server. And it works the same way in R12. Once I install the application server, I get everything no matter what. Even if I'm not running student system, if I haven't configured it, I haven't installed it or anything like that, student system is installed, and a lot of the security vulnerabilities are in web pages that you really don't need to have it licensed, configured, or anything like that. Typically, the security vulnerability is pretty early in on the process. So before the web page would blow up saying, oh, nope, this isn't configured or this isn't licensed, I can exploit the security vulnerability before then. So even though I'm not running Oracle Student System, it's installed, I can get to its web pages, and if there's a security vulnerability in one of its web pages, I most likely can exploit it. And so that's kind of powerful. You need to think about that as soon as you deploy to the internet. If you don't go through a very specific configuration, which we'll talk about, this is what you've got installed. You've got 250 modules on the internet, 20,000 web pages, a lot of things going on. And that's the true risk of Oracle E-Business Suite when you deploy it to the internet. Because if you don't do it right, you're opening yourself up to a lot of different things. There's a lot of different types of web application security vulnerabilities, as we saw from what OWASP and the threat classification is looking at. And there's a lot of unpatched security vulnerabilities. So another aspect of the Oracle E-Business Suite web architecture is that Oracle only certifies a certain set of modules to actually be on the internet. There's 2 reasons for this. One is there's some architectural requirements. They don't want Oracle Forms to be on the internet. And there's actually now one module that they're allowing Oracle Forms to be used on the internet. And then there's the URL firewall, which we'll talk about in detail. Rules have to be provided for that module. So Oracle spends some time looking at the security of each module before they actually certify it as being an external module. So if you're deploying modules to the internet and they're not on this list, you actually need to work with Oracle to try to get that module certified. And we would strongly recommend you don't do that until Oracle's gone through that process. Because there are significant risks, especially in some modules. And as we look through the web application architecture, different modules use different architectures. So some are Java server pages, some use OA Framework, some make heavy use of servlets. So each module has a different mix of those. So iSupplier has 2 Java server pages, mostly OA Framework. But then you get into iStore. iStore is mostly Java server pages and very little OA Framework. So depending on each module, the architecture will change slightly, and there's different security implications of that. So that's kind of a high-level overview of the Oracle E-Business Suite web architecture. Now let's start talking about some of the risks of deploying to the internet. This is kind of where things hopefully won't keep you up at night if you've done it right, but if you haven't done it right, you need to be a little concerned. So now what we'll do is map the OWASP top 10. So these are the Web Application Security Project's top 10 security vulnerabilities in web applications, and we'll map to the Oracle E-Business Suite which ones are kind of low, medium, and high risk. Of the top 2 high-risk ones are SQL injection and cross-site scripting. Those are pretty significant in the application. Over time, a lot of vulnerabilities have been found. The one area where Oracle has done pretty well is really authentication session management. The Oracle E-Business Suite actually has a pretty good mechanism for that, especially in OA framework of providing authentication session management. So there's typically very few risks there. There may be 1 or 2 items, especially related to maybe one servlet or something. But typically in general, Oracle's done a good job on that. A4, insecure direct object references. This has been an issue over time. Oracle has done a much better job in Release 12. But one of the areas that used to happen all the time was, let's say in iSupplier, I had a URL and one of the parameters was basically invoice ID. Oracle was just passing invoice ID. And a classic vulnerability, and this actually was in Oracle E-Business Suite 11i, I think it was patched in like 2004, I could just change the invoice ID as part of the URL and then bring up somebody else's invoice. Kind of somewhat powerful because you could just change it. But those are the type of vulnerabilities that exist as kind of direct object references. I can just kind of go up, bring something up that I shouldn't be able to. Instead of passing a key that's unique for that, and I couldn't guess another key, they just were passing the numbers. Now Oracle actually encrypts that information as it goes back and forth, so you aren't able to change it. Cross-site request forgery is another area that is fortunately low risk for Oracle. Oracle, because it's a Java application and the way it's architected, actually isn't that vulnerable to it. CRSF has actually been a problem for sites like Amazon and eBay. You're probably not going to be attacked in an Oracle E-Business Suite environment. A6 is security misconfiguration. This is an area where unless you do the security configuration right and change enough settings, Oracle can be very vulnerable. There's a number of issues. A7, insecure cryptographic storage. Oracle's actually done a very good job about storing correctly session IDs, secure information that has to be passed back and forth. So actually Oracle's got a good track record of that. A8 is failure to restrict URL access. This is another area where kind of a medium risk. There's been a number of vulnerabilities over time that allow you to restrict or access information you shouldn't be able to directly. A9 is a medium risk. Everyone needs to understand when you're actually talking to an Oracle E-Business Suite website, when you log in and you're not using HTTPS, so when you're in your browser and you don't see HTTPS, it's just HTTP, and you log in and type in your username and password, your password is actually going across either the internet or your internal network in clear text. So anyone with a sniffer can actually pick that up. And that's what A9 is talking about, is hopefully you're implementing SSL for any internet deployments. And then finally, A10 is an area where Oracle doesn't really recognize it as much of a significant issue, but it happens all the time in Oracle E-Business Suite. Is basically, as part of the URL, it actually points to another web page and includes the full web page. And what I can do is actually just put in google.com, and actually it'll direct the user to google.com. So that's an area where Oracle isn't really fixing the problems very quickly because they don't recognize the true risk of redirects and forwards. So these are kind of the areas that when you map Oracle to the OWASP top 10, some of the major concerns, especially the high-risk areas. So now if we map it to the Web Application Security Consortium's threat classification, again, a number of key areas: abuse of functionality, cross-site scripting. Fingerprinting is a very significant issue with the Oracle E-Business Suite. There are a number of information disclosures. I can very quickly, one of the things we do is when we talk to a new client is we actually go out and look if they're deployed on the internet, and very quickly we can figure out exactly what version of Oracle E-Business Suite you're running, often what patches, by just actually accessing a few URLs, and we can actually get all that information very quickly. Why? Why does that matter? Well, it helps a lot when you're actually trying to attack an application to know exactly what version, what patches, what might work and might not work ahead of time. So information leakage is kind of a major area within the Oracle E-Business Suite that hasn't been addressed by Oracle. They've fixed some of the issues, but there are still a number of issues that exist. So this is kind of how it maps out. So some of the issues, there is no risk. It is a Java application that does give some protection against things like buffer overflows and format string vulnerabilities. Path traversal, most of those vulnerabilities have been fixed over time and really aren't much of an issue anymore in Oracle E-Business Suite. So there's some good things and some bad things here. So, but you have to be aware that there's still SQL injection is a significant issue within the E-Business Suite. Information disclosure, misconfigurations are a significant issue also. So if these things are what you need to be worrying about when you're deploying to the internet. These are what will bite you at the end of the day. An attacker will use to exploit the application and potentially steal significant data, change things, that type of stuff. Another area where there's an inherent risk within the Oracle E-Business Suite is it's a package application. I can go to Oracle's website, edelivery.oracle.com, and actually download the Oracle E-Business Suite and install it. I do need about 100 gigs of disk space, and there's a significant barrier to entry there just in terms of disk space, but there's nothing stopping me from actually going and getting all the documentation, downloading the application, installing it, figuring it out. So if someone wants to go after you, and they know you've got an Oracle E-Business Suite environment, and pretty quickly you can go check on the first page, Oracle's got a copyright notice. If you go look at the source code, you can very quickly figure it out it's Oracle E-Business Suite. And so if someone's dedicated enough, all they have to do is know if I want to go after you and attack your Oracle E-Business Suite environment, I can download it, get all the information, find out, do Google searches and get information. And it's very easy to figure out the application, figure out what I want to exploit and attack. And I don't even need to attack you. I can get all that information ahead of time, and then I can come in for one fell swoop and actually go in and find a SQL injection bug that isn't patched. I can confirm that it exists in my test environment and go in and basically steal all your HR data with just one URL. That's pretty powerful. And that's kind of one of the inherent risks with a package because you know it. For a custom web application, they're all different. It takes a while to kind of hunt and peck and figure out what's going wrong with it, what I can exploit, what I can't exploit. But for Oracle E-Business Suite, I know I can figure that all out ahead of time. And if with a little bit of knowledge and a little bit of motivation to go after a specific site, it's fairly easy. Or as organized crime gets into it more, they're looking for large groups of targets. Well, a lot of big companies are running Oracle E-Business Suite, and we anticipate in the future more people are actually going to target Oracle E-Business Suite because that's where the money is. There's data there. I can actually potentially exploit your EFT process and start sending out checks. But because everything's running as apps, I have full control of the application if I can find one SQL injection bug. And there's been over 60 fixed in the application. There's got to be more. It's a very large application, 20,000 web pages, and only 60 have been fixed. How many more exist? So that's kind of some of the risks of deploying to the internet, some of the things that you need to be thinking about as you're putting it on the internet. Now let's start talking about how do you secure it in the internet. So you've deployed it now in your E-Business Suite. What are the steps required to secure the application? Well, Oracle's got two documents out there on Metalink. One is for R12 and one's 11i. And these are very specific and detailed configurations, what you need to do to secure the application. And if you don't follow every step in these documents, you're potentially leaving yourself open to some holes in the application. And I'll talk through kind of the key steps. Rather than going through each step and describing it in detail and showing you the kind of the commands, what I'm going to do is pick off a few areas within the configuration that are critical and what they're doing and why they're doing it. This is more of a how and why versus what to do presentation. But these are, and if you've deployed to the internet and you haven't followed these steps, so if you're a security person or a technical manager, make sure your DBAs are following these steps because they're not Apache web security experts. They're basically DBAs, and they're typically the ones required to actually follow the steps through. And one of these steps is actually, it looks optionally Appendix C, and it's not. It's Appendix E, and Oracle just has it labeled way at the end versus having it as part of a critical mandatory step. So let's first talk about EBS DMZ architecture. Oracle fortunately fits in fairly well with most standard DMZ architectures for web applications. So if you kind of picked up any book on web application security and they start talking about a DMZ architecture and how you should do it, Oracle fits very well into that. There's really nothing specific to the Oracle E-Business Suite environment that would say, oh, well, you have to do this differently than any other web application you would deploy. Rather, Oracle is a very standard EBS DMZ type configuration. So there's a couple areas that you always need to think about. One is, how are your clients connecting to the application? So what are they typing? They should always be using HTTPS or SSL. And the reason for that is, if you use just HTTP, it's not encrypted going over the internet. And so any data that's typed in and sent to the application server and returned is always in clear text. So if someone can sniff on the internet, they can actually see that data unencrypted. So when you log into the Oracle E-Business Suite, you type in your username and password, there's no magic happening. If you're just using HTTP, it's actually getting sent across the internet unencrypted. Anyone can kind of sniff that and just see the password right away. SSL provides that encryption between the application server and the end user's browser. Most people, and kind of the best practice is to actually do the SSL encryption and decryption on a reverse proxy or a load balancer versus doing it on the E-Business Suite application server. So as you kind of see flowing left to right, the client talks to a reverse proxy, then the reverse proxy talks to the application server. The decryption encryption is actually done on the reverse proxy. That could be an F5 device if you're using load balancing, could be a device from a company like Blue Coat, or you could actually be using an Apache, a mod proxy, reverse proxy. The advantage of doing the SSL encryption and decryption on the reverse proxy then versus the application server is that it's actually much more efficient to do it on the reverse proxy. You don't have all the load of encrypting and decrypting data on the application server. And hardware like an F5 load balancer is actually very efficient at it. They actually have specialized processors within the appliance that can actually do the encryption and decryption. So B is reverse proxy. The reason you want to implement a reverse proxy is just to provide another layer between your application server and the bad guys. And the reverse proxy helps to hide the IP addresses of the internal application servers, provide another layer of validation of the data coming in and out. So it's not doing a significant amount, but it's actually just providing another layer that helps a lot. And then C is the firewalls. You should actually have at least 2 firewalls implemented, one between your DMZ and the external environment, and then one between your DMZ and the internal environment. And a number of security experts recommend having a firewall also in between your reverse proxy and your application servers. This one's probably optional. The one advantage of having as many firewalls is what you're doing with the firewalls is you're opening up specific ports, so you're blocking anything else. So the classic scenario here is if I can compromise your external application server, the only thing that an external application server could do is then access the EBS database server. It can't SSH into anywhere. It can't all of a sudden now run amok within your internal network. So even though it may be compromised, the idea is if something is compromised, the only thing that should be compromised is the data that that system has access to. I should never be able to compromise anything beyond that. And that's really what the firewalls are providing. They're providing just a layer of barrier between the different layers and just limiting what can be accessed, especially in terms of a compromise. Also from this chart, you can see that there's an external and internal application server. One of the key aspects of the Oracle E-Business Suite DMZ design is the external application server must be separate from the internal application server. That's always key to keep in mind when you're designing it. So now when we start going to the next layer, as part of the configuration, there's actually 2 very specific steps you have to follow. And as we talked about before, the standard Oracle E-Business Suite environment, you install the application server. Even if it's an external application server, you've got 27,000 web pages out there. One of the things in security is actually to reduce surface area. I don't want 20,000 web pages on the internet. I'm not running Oracle Student System. I don't need those web pages accessible on the internet. So as one of the appendices of the Oracle DMZ documents is implementing a URL firewall. This is an appendice. This should be a mandatory step. This is often missed as part of the process because it is kind of buried in an appendice at the end. But basically, the URL firewall is a whitelist, and what it does is here, I'm trying to limit what's on the internet. So the URL firewall is a set of mod rewrite rules, which run as part of Apache, and basically it's just a whitelist and says, I'm running iSupplier. So if you're running iSupplier, you need access to the login page. You need access to a page called supplier registration, a JSP page called registration reply, and some OA framework pages. That's it. I don't need all the access to servlets. I don't need access to Oracle Forms. I don't need access to web services. I don't need access to 8,000 Java server pages. I only need access to about 90. So if you kind of add up the online help and the login and log out, all those pages, it ends up being about 90 that you have access to. And so what the URL firewall is doing is I just have a list of what pages I can access and not access. So it's kind of diagrammed out here is, okay, I've eliminated a lot of access. I've eliminated a lot of surface areas, a lot of potential vulnerabilities that might exist that I don't need access to on the internet. And that's why the URL firewall is so important. One area you'll see here, though, is the OA framework. I haven't limited the OA framework. The OA framework works off 2 Java server pages, OA JSP and RF JSP. Then those provide access to the 11,000 OA framework pages that are in R12. And these are also in 11i. So now I need a second way to actually limit access to the OA framework pages. So there's actually now steps 5.2 and 5.3. The nice thing about the 2 DMZ documents from Oracle is that the numbering is the same. So for 11i and R12, they're different documents, but the numbering of the steps is the same. So I've implemented the URL firewall, which blocks access to everything except for the OA framework. Now I need to have a way to block access to the OA framework. And the way Oracle does this is it has node trust level and then a list of responsibilities. So the way this works is I go in, step 5.2 is setting up in a system profile option, node trust level for each application server, and I declare those application servers as external, which now starts using a list of responsibilities that are allowed to access the external application server. And then I list out the external responsibilities that I want enabled. So for iSupplier, there's really 2 responsibilities. I think it's iSupplier guest and iSupplier supplier, something like that, that I would actually set up for iSupplier. And therefore, those are the only 2 responsibilities that would be accessible via my external application server. The other advantage this has is it doesn't let my own employees now access the external application server like using system administrator responsibility. Those people would then have to go through a VPN to actually access the application. So then, as part of the responsibilities are linked to functions. Functions then declare what pages you're allowed to access. So now if I only have 2 responsibilities available externally, now I've cut my 11,000 OA framework pages to maybe 250 that are used by the iSupplier module. So I've dramatically, again, reduced my service area of the application. I don't need access to thousands of responsibilities externally. I just need access to those 2 responsibilities that have to be used. There are a number of pages within OA framework that are enabled for guest. I still can access the preferences. So there's actually a lot of different pages I can access. Out of that 250, only about 50 or 60 are iSupplier pages. The rest are actually all standard Oracle E-Business Suite pages, which still may have vulnerabilities, and it's still not a complete solution, but at least I've limited it down to the bare necessity. So now when we actually take these 2 things together, the node trust level and the URL firewall, now you can kind of see as a whole on the application server, instead of having access to 20,000 web pages, now we actually decreased it down to maybe 300. So a dramatic reduction in the surface area, the risk of what can be actually accessed and what can be exploited externally. And these are 2 pretty powerful things, but as you go through the configuration, unless you follow the DMZ configuration document specifically, these are not enabled by default. So if you just kind of pop up an application server, connect it to the internet, and start running, well, this is not enabled. You actually have to go through a very specific configuration to get this all working correctly. And it's a step-by-step. So that was kind of the web architecture at a high level, kind of the DMZ designed by Oracle. I didn't go through every single step, but I kind of showed you the kind of the two most important ones as part of the configuration. What you're trying to do is just limit the access. So now if we go back and actually take the Oracle DMZ configuration and actually map it to our OWASP Top 10, Oracle does provide some capabilities and some protection from the key risks that are keeping me up at night. One is cross-site scripting. Oracle's got an okay filtering for cross-site scripting. Basically, cross-site scripting is I'm just really injecting HTML tags, and some of those being script tags, so then I can run JavaScript. Well, Oracle's implementation of that is okay. They're blocking basic ones. There's actually websites out there. You just do a Google search for cross-site scripting cheat sheet or something like that. You'll actually find 3 or 4 very good websites that actually list out thousands of possibilities of cross-site scripting attacks. Oracle has a partial implementation of those lists, but it's very easy to evade. Integrigy's actually had a bug open with Oracle since 2007 to get them to actually improve their cross-site scripting checking capabilities, but they haven't done that yet. Oracle's on A8, failure to restrict URL access. Oracle's actually done a pretty good job now with the URL firewall and the OA framework responsibilities limitations. They've restricted access to most URLs within the application. Now you're down to a lower surface area. I say mostly because there are some issues and some things that they can't do very well on just the URL firewall rules. They aren't granular enough unless you put down every single page, which then would be hundreds and hundreds of pages. There are some things that you can get to that I don't think you should be able to get to. So that's kind of a mostly. It's somewhat complete, but there are still a number of specific holes. The one area also on the DMZ configuration, A9. So basically, Oracle does provide a very good SSL solution. You do need to do recent patches because Oracle is using a little bit older version of SSL instead of TLS, the most recent version. So you should probably be upgrading your SSL implementation if you haven't done that in a while and actually creating new certificates and things. There's been some improvements in that area and some vulnerabilities found over time. And if you implemented 2 or 3 years ago, your SSL implementation is probably not complete. So that's kind of a mapping. So as you can see, there's still some key areas that the Oracle DMZ configuration, Oracle applications as a whole hasn't solved, and there's still kind of potential issues within the application. So now if we kind of talk about what can we do next? Is there another layer of security that we can add? And there typically is. It's web application firewalls. So you've implemented just standard network firewalls. Those are blocking ports and things. Well, the next steps past that, the next generation, was web application firewalls. So these are a specialized set of firewalls that basically look at HTTP web requests. They're taking apart the web requests and trying to find different issues, trying to block common attacks like SQL injection, cross-site scripting. They're very good also at known vulnerabilities in widely used web applications. Unfortunately, widely used web applications isn't Oracle E-Business Suite. They're often implemented as an appliance. So if you actually buy an F5, you can actually get a module as part of your F5 to be a web application firewall. Another product out there is Imperva. So there's some very good web application firewalls on the market. For those of you running credit cards in your Oracle E-Business Suite, you should be PCI compliant, Payment Card Industry Data Security Standard. Your credit card provider should be forcing you to be PCI compliant. And if you're running any credit cards in Oracle E-Business Suite needs to be PCI compliant. And one of the requirement 6.6 is to actually use a web application firewall or do periodic quarterly security reviews of your application. So web application firewalls, and a lot of larger organizations do already have a web application firewall installed for the enterprise to block attacks against all their other web applications, and you should be looking to implement that for Oracle E-Business Suite. Unfortunately, for web application firewalls in Oracle E-Business Suite, there are some shortcomings. It's not a perfect solution. First, they don't know anything typically about the Oracle E-Business Suite. And the Oracle E-Business Suite is a very complex, big application. It doesn't work very well with a lot of web application firewalls out of the box. There aren't any rules predefined. There's no application profiles. And typically you have to do some learning with the web application firewall to actually get it to work right, to block certain things, allow certain things. So it does take a lot of effort to heavily customize it for Oracle E-Business Suite. Another problem is if you're not using the URL firewall or you're looking to take the URL firewall to the next level, well, web application firewalls really can't do that for you. They can't block on a specific module because the Oracle naming standards and design isn't straightforward enough to say, yes, everything for iSupplier is POS, and I should block any web page that's not a POS web page. Well, unfortunately for Oracle, it doesn't work that well because you've got the OA framework, you've got Java server pages, you've got servlets all running, and they use different naming standards. And it's fairly complex to figure out what those naming standards are and try to implement it as WAF rules. And also what we see, especially with the web application firewalls, for smaller organizations that don't have one today, it's a very expensive proposition to just say, well, we need a web application firewall for the Oracle E-Business Suite. You might be talking $50,000, $60,000 plus another $20,000 or $30,000 to at least get it installed and configured. So that's a pretty steep price just for a web application firewall for one application. If you're doing it at an enterprise level, it does make a lot of sense, and most big organizations do already have one employed. So for the web application firewall, if you're looking to add another layer of security, well, Integrigy actually does have a product that we developed. We actually developed AppDefend originally back in 2004 before Oracle developed their DMZ configuration documents and before they had the URL firewall because we recognized this problem early on. So we went to solve it and actually developed a product to block the modules, very similar to the URL firewall, but we actually have more capabilities and flexibilities than the URL firewall to actually identify modules and block them. Then we have also added in SQL injection blocking. So we're trying to add in additional layers into the web application firewall, and that's why we call it an application firewall, to try to block things against the application and try to map back to the OWASP top 10, the threat classification, say, okay, what can we actually block and customize it and optimize it highly for the Oracle E-Business Suite. Another thing that AppDefend does is actually does application logging. So when you do a sign-on, well, that goes in the FND sign-on, and if you need to be PCI compliant, or in some SOC situations, they want a full audit trail of all sign-ons stored outside the application, well, AppDefend can do that. AppDefend can capture all your sign-ons and actually send it immediately to a logging solution. If you're running something like ArcSight or Envision or Q1 Radar, AppDefend can actually send that information off. Another area that's actually fairly new to the Oracle E-Business Suite that's being deployed much more on the internet, and Oracle, we don't believe, has a very good solution at this point, is web services. So Oracle has implemented SOAP and REST and SOA to actually open up the E-Business Suite with web services. Well, AppDefend actually does provide another layer of protection for web services. And as part of 12, to give you an example, as part of 12.1.3, Oracle actually released RESTful services. And so brand new code in the last couple of years. Well, as part of the January 2012 critical patch update, there was actually a bug patched as part of the RESTful services. So this is kind of new functionality, brand new web services, and there's actually already been a security vulnerability patched in it. So there are, web services are a very good concept. They provide a lot of functionality, but there is a lot of security risks for anything new like this. You do have to be aware of as you're trying to deploy it to the internet, and Oracle doesn't have a great solution at this point for security. They actually want you to buy their enterprise gateway solution to provide security versus providing it natively as part of the Oracle E-Business Suite. So that kind of takes you through the process from what are some of the risks of our Oracle E-Business Suite to kind of some of the solutions, what kind of configuration you need to do to configure the Oracle E-Business Suite when you're deploying it to the internet. So basically, kind of hit the 50 minutes now, so we'll open up to questions and answers now, and we'll kind of give you some contact information. So anyone who does want more information, we are always open to questions, and you can contact us at info@integrigy.com, and we also have a blog that we talk about a lot of these Oracle security, E-Business Suite security issues. And so I'll turn it back to Phil.
Thank you, Steve. Very informative. It gives a lot for us to think about here. Who has some questions? The first one, from a security perspective, is there a difference between the I modules?
In terms of the different I modules, there is a little bit of difference in some of them because the web architecture's changed. Oracle has been aggressively moving to the OA framework for all the modules, but some of the older ones are still in Java server pages. There's a bunch of servlets still, especially 11i. This is especially problematic. In R12, it's gotten much better, but there is a slight variations in each module, and you kind of have to be aware of that when you're trying to secure it. So we take a little bit different approach, especially in our AppDefend configuration, between like iStore and Java server pages, and then the way iSupplier would work with OA framework. So you have to be aware, and there's more security vulnerabilities in the Java server pages. The OA framework is actually a pretty robust framework. Authentication is handled centrally. Authorization is handled centrally. Logging is handled centrally. The problem with Java server pages is that each page has to handle like authentication and authorization. And there's been a number of security vulnerabilities over time. So if the page that the developer just didn't put in, check if this function, if this user has the correct function and responsibility to execute this page, they forgot to do that or said, oh, no one's going to call that directly, then you can actually exploit that page. And that's maybe been 10 or 15 security vulnerabilities over time on those type of things.
All right, number 2. Do I need to secure externally developed web services different than the external Oracle EBS modules?
So basically the difference between EBS modules and web services is there's a dramatic difference, especially in R12, because in R12 it actually runs as a separate Java container. So they're running separately, and the architecture and the attacks are very different. So as part of web services, I have to worry about XML injection, XPath manipulation, things like that, which are very different than cross-site scripting and SQL injection. And the way you inspect the traffic looks differently. A lot of the web application firewalls are now starting to get into it. We've got the capability built into AppDefend, but it's a very new area for everyone. I'm trying to figure out how to secure it, what's the right way to do it, how you do authentication with it. So you have to be very aware of that when you're actually trying to secure the web services.
Number 3, how can I convince our organization it's safe to open up to more of the EBS to the web with the appropriate security measures in place?
So one of the major issues with the EBS is you've got full access to the back end. So if there's any security vulnerabilities or any issues, that I can now access all data in the back end. There's no way to segment that out. So in terms of a CIO looking at this, that would be my biggest hesitation about deploying to the internet. And the only way to kind of fix that is to add additional layers, so make sure that you've got the appropriate firewalls in place, you've got the appropriate reverse proxy, web application firewall, and you've done the DMZ configuration for the Oracle E-Business Suite. If you've done all that, except for unknown security vulnerabilities, and hopefully your web application firewall is trying to block some of those SQL injection and cross-site scripting vulnerabilities generically, so any page it looks at, it's checking every parameter for every page to make sure that there's not SQL injection in any of those parameters. You can be fairly safe. There's always the possibility, but at least you've reduced your risk, you've reduced the surface area, you've limited it as much as possible, and you've tried to detect or block as many attacks as possible. Nothing's perfect here. You're kind of in the same boat with every web application. There's always the fear of the unknown. If there's a abusive functionality bug in the application, yeah, someone can exploit that. And then you just have to be applying the critical patch updates as soon as possible.
All right, next one. Can I use the same application server for both internal and external?
One of the major limitations of the Oracle E-Business Suite DMZ configuration is the internal application server and external application servers have to be separate servers, because the way Oracle does the external naming is it has to be by server name, therefore they have to be separate machines. They can be logical VMs, they can be physical servers, but they do have to be separate. And what we've seen a number of times is people say, well, we just have to deploy it, so therefore we can't do the responsibility of the node trust level. Well, the node trust level is there for a very good reason, to block access. And if you don't enable that, you're opening yourself up on the internet to all the different modules, all the different responsibilities. And so the only way to do a secure configuration is to have separate internal and external application servers.
All right, we have one last one. Are there any risks with the Oracle E-Business Suite user authentication?
One of the areas that we've actually been fairly surprised with on how well it's actually worked is the basic authentication. So when you sign on with a username and password, that works fairly well. There's been a couple bugs over time in that, but generally that's been pretty secure. We haven't found a significant number of flaws. There's been some cross-site scripting with it, and one or two minor flaws, but nothing significant in terms of saying it's broken or you can really crack it easily. Generally and overall in the application, there's a number of issues like encrypting the passwords in the database is a significant issue. But in terms of the authentication and the front end is not too bad. It works fairly well, and we haven't found significant problems with it. So that wouldn't be keeping me up at night. SQL injections in a random page would keep me up at night much more than just the authentication piece.
All right, thank you, Steve. And I wish to thank everybody today for attending our e-learning session today. We have discussing the possibility of having an advanced session regarding this since there seems to be so much attention by everybody. So again, we'll let you know when we get that developed. So again, thank you very much for attending today, for taking the time out, and again, if you have any questions regarding EBS or the AppDefend project, please let us know. Thanks again.